Hi, and welcome to the mid-month edition of According to Pete. If you remember the last time I said, okay, we're gonna try this and see how it goes. The reason why I've been resisting on doing this is because, well, the fact of the matter is I have another job I have to be doing. If I'm answering like the questions that people send in, the first thing I look at a question and go, well, I don't know that. I gotta go find this. And then I have to spend a whole bunch of time researching because I don't want to say something stupid in these videos. Those sorts of things, while they're, I'm certain, useful to you guys, end up being a lot of time invested for me. Whereas if I'm doing a project like the Everlasting Amplifier project, it's a lot easier. I can wing it because I lived it. And I think there are worthwhile lessons in those things. But it's not why we started doing the video. We started doing the video so that I would actually answer questions. And the project is not that. And I've got a long list of projects I could be doing. There's like the guitar that I want to bling out with LEDs and stuff that does frequency response. There's the drive system for a Dobsonian telescope. There is the tube amplifier project that I'd love to do. And quite honestly, I have a lot more personal fulfillment when I'm making stuff. I love it a lot. But I'll leave it to you guys. Do you want me to just answer the questions? Would you like to see more projects? Give me some feedback, tell me what you want to see more of, and we'll go from there. In the meantime, let's talk about what we actually came to talk about, which is the Everlasting Amplifier. We got the MP3 board, or MP3 player, attached to the PCB, yeah, with double-sided foamy tape, like servo tape. We've got the regulator, which is on the bottom of there and really poorly soldered, but you get a close-up look at that in a bit. And it's all powered. Now, there are three signals of interest that I want on the MP3 player. The first is like play / pause, right? And the function of this on the MP3 is like, you push the button, you push the button once and it powers up and it starts playing whatever it was last playing. You push the button again and it pauses and it sits there for about 3, 4, 5 seconds and then it shuts off. So cool. I got, on, off, play, pause with one button. Pretty cool. The others are, track forward or track reverse. And these are two separate things. Now on the MP3 player, there is, there's like one of these these 5-way joystick things that, it looks sort of like that. And on the PCB, it's like this, and it's got 3 leads here, and except they're not leads, they're like, what's like a QFN package, sort of, kind of. And you go this way and it goes track forward, you go this way, it's track back, volume up, volume down. I don't care about volume. I got that control on the faders, right? And the thing about the MP3 player is if you have the volume cranked up, when you turn it off, it'll always revert to like a setting of 21 out of 30. 30 is the max, so it always goes down to 21 because it thinks, oh, this person is stupid. They don't want it up that loud. Yes, I want it up that loud. This is the button. This is the switch that gives me track forward, track back. The other one, the play pause, this is a single button that sits on the top here, which I'm sure you can't see right about there. Yeah, so it's just a little tactile thing. When I powered this thing up, I started poking it with a voltmeter to see, okay, when I actuate this, what happens, right? On the play pause button, it pulls it low. I took that button, I put it through a 10K to one of the logic lines on the Pro Mega board. You activate that thing, you pull it low for like 200 milliseconds or so, and it turns off, or it turns on, or it pauses, or what have you. That was easy. Now, what I found poking around is that like this line is, it's got a 10K and it's like an 0402 package, teeny little thing, but it's 10K to ground. And I know ground doesn't point up. And when you push the thing this way, it connects these two, right? And I found this is track forward. So this is, that means track forward. This one goes to volume up. This one goes to volume down. Yeah, it's pretty obvious, right? It's exactly what you would expect. Yeah. And that one's there. This one, turns out you can push the button and it connects that to that. So that's how the switch works, right? It connects this pin to either here, 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 or here, depending on what you do with the joystick. I'm looking at this going, okay, 10K to ground. So all it's doing is taking a logic line from a microcontroller somewhere, and I measured this with a voltmeter, and it's sitting at 3 volts, right? Remember the booster we talked about? Yeah. Okay, so it sits at 3 volts until you like push it this way, and then this goes to 0 through that 10K. Simple enough, right? Here's what actually happened. When I set this up, and I just went, you know, straight for the throat, I hooked it up to the microcontroller with 10K resistors, pulled to ground, made sure all the grounds were clean and good, and none of it worked. Why doesn't it work? My first inclination was that I didn't have the duration of the pulling low action correct, because right, if you do it quick, like it'll skip to the next track. If you hold it down, it'll scan through, okay? And so I thought I was just getting a weird spot where I wasn't, and I fooled with the timing, didn't work. So it's like, okay, so what's going on? Now this resistor happened to be a little bit off center. It wasn't quite on its pad correctly. And so I tried to reflow it, and I did reflow it, and nothing happened. So next, what I would do is I took these individual lines, right? So for example, I solder a wire on here with a 10K, and 10K, and now I take this point and I start poking around places to see, you know, what happens. Well, it turns out if I take this and I put it to ground, it doesn't do anything. It doesn't actuate, I mean, it doesn't cause the thing to track forward or any of these others, okay? But when I take this point and I put it to there, effectively just closing the switch, suddenly I have function. Okay. So this tells me like, okay, this resistance isn't really that critical. Because it can go from 10K to 20K and it doesn't care. So this isn't a problem of me not having the right load on these lines. The next thing I did was I yanked this resistor off and I measured the resistance of this line to ground, right? Because if this is the only resistance to ground from this point, I should see an open circuit. I didn't see an open circuit. I saw 65K. And that is not what I would call a standard value, but it's a suspicious value. What it tells me is that there's more going on in this circuit that I understand, and I can't see it, and I'm not likely to see it. So what do I do here? It turns out, ladies and gentlemen, that we sell a part on our storefront. Here is the TS3A5017 COM10652, okay? Analog switch. This thing is awesome. I've drawn up this circuit and, okay, maximize this video on the screen so you can see some of this junk, right? Now, I've only drawn the one half of it effectively because that's the only half I used, right? I only have 2 things that I need to switch, track forward and track back. From that switch, right, you remember that I had this here and like this one lead up here, that's the magic lead, that's the one that everything gets switched to. This guy, if you check the data sheet for the TSA 3.0, you put this guy on the line that says 1D. That's a D. Believe it or not, that's a D. Not an arrow, not a ground sign turned on its side. But that's that line, okay? Now the other 2 lines, track forward and track back, I strung to, I think, here and here. And it's really irrelevant. The way this switch works, right, you have to enable one enable that enables like the first bank, and you see the internal structure of this thing, anything here, and it goes with that noise. It's crazy, you should hear it. So you pull this guy down, it enables this. Then you've got these 2 lines on pins 2 and pins 14, pin 2 and pin 14. One is called in 1, one is called in 2, and depending on how you set those up, you choose a different position for this guy to be connected to, right? Anybody in their right mind would probably go like, oh geez, we don't know what kind of resistance there is in this switch. But you remember I did that experiment with the thing, and it's like 10K, 20K, doesn't matter. This thing actually offers only, you know, milliohms or a couple of ohms of resistance, so it really doesn't make any difference. And in the end, when I hooked all of this up, it didn't make any difference. I did, now you remember also that I took off this resistor that would be effectively up here that you don't see, 0402. I managed to crowbar an 0603 on there without too much difficulty, so that's fine. And I was able to get my function this way. I took the 3.3 volts right off of the mega board, tied this to ground, and like that. Now, worth mentioning, this is a SOIC part, right? So it's a very small part. Easy enough to solder, but you know the PCB that I'm doing this all on is not a surface mount prototyping board. It's a through hole. So all the holes are spaced 0.1 inch. Well, the pins on this guy are spaced 50 mils, half of that. So very conveniently, that one goes to a hole, that one goes to a hole, that one goes to a hole, and they're effectively just pads, right? And so what I did was I pinned the corners, and then the pins that I needed, I would pin down to pads, or I'd pull them up. Like for example, that ground is gonna be down on a pad, that's gonna be down on a pad. This one, I actually pried up a little bit with a pick or like an X-Acto knife or something, and then you just solder a little lead on there, some wire wrap wire, not too difficult if you've done this before. And that established all of my function. So now I've got the play pause, and I've got track forward, track back, thanks to this guy. For those of you who say, you didn't bypass that, man. Oh yes, I did. There. As if drawing it with a Sharpie on a whiteboard bypasses the part. Well, there you go. All right, so now let's do a little close-up of that circuit so you can see what I actually did on the board. Here is the TS whatever it is, because I got to keep looking at the board to figure out what that part number is. Here's the regulator that I set up the last time, and for anybody who's wondering about those values, it looks like I've got 2.2K from voltage input, which is 5 volts, down to the adjust pin, and then a 470 down to ground, and I've got a single electrolytic in there, which is probably 10 microfarad or some such. I can't see the number from where I'm sitting. And here's my 150 ohm bleed resistor that stabilizes that regulator. So here's our analog switch. Nothing too very fancy, as you can see. In fact, it looks pretty awful. But it does work. So I've got, and I'm sure this is going to be very difficult to see, but try blowing it up on your screen and see if you can see this any better. Wire wrap wires, there's my bypass cap. It might be a polyester. It is a 0.1, I remember that for sure. Some of these pins are down on pads, the rest of them that I need are pulled up, and I'm careful not to make contact on things that I shouldn't be making contact on. Conveniently enough, a bunch of digital lines are right next to the part, so that's why I put it there. Besides that, not really that much to see. That's the circuit work. It's not my best, but it is effective, and all the connections are at least connected. So now all it's left for me to do is demonstrate, which is long for demo, that I do actually have the functionality that I said I was going to have. So I have this up on my Bluetooth. The Bluetooth is already connected. And so the first thing I'm going to do, and watch this, this is the MP3 screen. You should be able to see that start making pictures when I press play pause. And there it goes. So it's coming up and it's going to start playing something. So now I'm going to turn the audio on, the audio channel on, which is there, and that LED there, which is kind of hiding behind that wire, whatever. And then I'm going to turn some volume up. And it's Muse. I like Muse. But I need to demonstrate that I can do the other thing. Do the thing to make the thing, do the thing. Okay, that's what I'm going to do. So I'm going to skip this track by hitting forward. And it's Led Zeppelin. Hey, hey, what can I do? As a matter of fact. But what's after that? Elvis Costello. Very nice. Okay, so we go backwards too. And it's Elvis Costello again. I'll hit it again. And there's Led Zeppelin again. And there's Muse. It starts off really quietly. I'll see if I can get to a louder song. Me first in the Gimme Gimmes. Thank you. So there you go. That illustrates that I actually did what I said I was going to do. Now, I haven't got a display going for this thing yet. And maybe I'll talk about that in the next episode, because I've played around with some stuff and I have some things to show. Not sure if I'm happy with it or not. I may take it in a different direction. Thanks for watching. Remember to give the feedback about what you want to see. Do you want me to answer more questions? Do you want to do projects? Projects will happen more easily and more frequently. If I have to answer lots and lots of technical questions, which is so burdensome, man, it's harder, and that's probably going to be a monthly thing. So there you go. Thanks for watching. Thanks for witnessing the carnage that is this video series. Until next time, keep on trucking. Keep the comments and questions coming. Comments go in the comment section below. You know, the questions go in the comment section below. Or you can send your comments and questions to feedback@sparkfun.com with "According to Pete" in the subject line. Thanks again for watching.